welcome back to our channel. Today we are going to discuss about physics crash course and the topic name is the mechanical properties of solids. Why we have to know about this chapter? You know that suppose we want to construct the buildings, we want to construct that some bridges and you want to make any instrument, we have to know about the properties of the solids. Then only we can go through the applications. Suppose bridge is there. For the construction of the bridge, we are using the iron. If instead of iron, if we are using the plastic, what happens? One day also it's not possible. So what is the difference? They have studied what are the properties of cement, stone, that iron, that plastic, and they decided that for construction of buildings and bridges, which material is sufficient. Not only this one, we can able to study any property of the solids with the help of this concept. Anyway, in our intermediate, we are focusing on what is the stress, what is the strain, what is Poisson's ratio, what is Young's modulus and all this. Then we are starting with what is the rigid body. Even we are applying the force, how much force we are applying, there is no change in its shape and size. Simply we can use that there is no change in its dimension. That is called what? Rigid body. But there is no perfect rigid body in our nature, but diamond we can treat as a approximate rigid body. So that is the definition for the rigid body. Then what is the elastic nature and what is the plastic nature? Suppose we are taking one rubber band, we are applying the force is like that. Then what happens? Dimension is changing, it is elongation and length is increases. When you remove that force, it comes to original dimension. From this, what you are understanding, it is having the elastic nature. When we are applying the force, we can observe the deformation. When we are removing the force, because of the restoring force, it comes to its original dimension, that is called the elastic nature. So Indian rubber and quartz fiber we are treating as a like elastic bodies, remaining all are the plastic bodies. What are the plastic bodies? When we are applying the force, along that dimension is changes. When we are removing the force also, it does not comes back to its original dimension, that is called the plastic nature. So almost one glass you should break, okay, wheat, duff and all belongs to what, like putty is there, belongs to the plastic bodies. Now we are going to discuss about the what is the stress. What is the stress means, don't think about your stress, we are thinking about in terms of force and area. This is the normal force on the body with respect to area. We are calculating the deforming force per unit area is called the stress. Stress formula is force by area. Force by area. Force by area. Unit is what? Newton per meter square. Dimensional formula is same like past pressure dimension, pressure unit you are getting. That is the ml power minus 1 t power minus 2. Then we are going to discuss about types of stress. There are three types of stress is there. First one is the longitudinal stress. Longitudinal stress. Then second one is the volume stress. Volume stress or bulk stress also we are calling bulk stress. Then third one is the tangential stress. Tangential stress. So there are three types of stress are there. Then what is the common formula? See, when we are observing that longitudinal stress means we are applying the force. We are applying the force normal to that one. We can observe the change in dimension along the lengthwise or along in one dimension. You can say that that is the longitudinal stress. Then what is the bulk stress? If we are taking one ball is there, we are applying the force and we can observe the change in dimension like a volume wise, that is called the bulk stress. Then when we are applying the force tangential to the surface, we can observe that we are calculating the that stress force per unit area, that is called what? Tangential stress. So whatever the stress, you should remember that the formula is force per unit area. The formula for force per unit area. Now we are going to discuss about the strain. What is the strain? It is the ratio of change in dimension to the original dimension. dimension is called the strain. But here we can remember that there is no unit for this. In examination they will ask what is the unit of this strain, means it is the ratio, there is no unit for that one. So no unit for this. But how many types of strains are there? There are three types of strains are there. First one is the longitudinal strain. Longitudinal strain. Longitudinal strain means change in length by original length. It should be right when one wire we are taking some elongation we are observing. Instead of change in length, elongation we can represent with small e also. So this is the longitudinal strain. Then second one is the bulk strain. Bulk strain. It is represented by change in volume by original volume. We are taking one ball and we are applying the force like this. Then what happens? Volume is decreasing how much? Delta V. Initial volume is the V. But we are calculating change in volume by original volume, that is called the bulk strain. Then tangential strain. Tangential strain is how to calculate this one. Actually tangential strain, look here, we are taking one body here. The distance between two layers is the L. But when you are applying the tangential force, this one, this is displacing like this. This is also displacing. How much it is displaced? X distance. Here tangential strain is represented by theta equals to X by L. This is the tangential stress. And where we should observe, normally in the case of books, when we are applying the tangential force, that layers are going towards like a somewhat forward direction. That displacement is the X. Actual length between the layers, you can say that, that is the, yeah, suppose you are taking this book, when we are applying the force, then what happens? This layer is going somewhat forward direction, that is the displacement. And here this perpendicular distance between these two layers is nothing but L. Like that we can calculate the types of strain and different types of strains I have given. Now Hooke's law. Hooke's law. Within the elastic limit, stress is directly proportional to strain. Here when you are removing this proportionality, you are getting stress equals to E into strain. Then E equals to stress by strain. Here also there are three types of moduli of elasticity. First one is the Young's modulus. This is the Young's modulus. Then second one is the bulk modulus. Second one is the bulk modulus. Third one is the rigidity modulus. Rigidity modulus. Like that there are three types of modulus are there. So one is the Young's modulus, next one is the bulk modulus, then third one is the rigidity modulus. So based on that we are getting that shear modulus also, we are calling this is shear modulus also. Shear modulus. So these are the three types of moduli there. It is represented by Y. Second one is represented by K. Third one is represented by eta. So these are the different types of moduli. Now we are going to discuss about what is the Young's modulus expression, what is the bulk modulus expression, and what is the shear modulus expression we are calculating here. Look. Y equals to, what is the formula? Look here. Whatever the moduli, stress by strain. Young's modulus means we can take it longitudinal stress by longitudinal strain. Longitudinal strain. Then how to write this expression? Y equals to F by A divided by delta L by L. Instead of delta L we are taking change in length is E, already I said. So it should be right F L by AE. When you are getting the, when you have to find out comparison of two materials Young's modulus, we can take the ratio Y1 by Y2 equals to F1 by F2, L1 by L2, A2 by A1 into E2 by E1, like that. Suppose here you want to give the relation only individual things, you can write it Young's modulus is directly proportional to force, Young's modulus is directly proportional to length, this is inversely proportional to elongation, like that. This you can express like this also, FL by, instead of area, pi r square into elongation. So y1 by y2 equals to r2 by r1 whole square. When length, applied force and elongations are constant, we can use this formula. This is belongs to Young's modulus. Not only this one, look here. From this we can write it, see, y equals to f by a into el by e. Otherwise it should be right delta L by L. Delta L by L. From this, f by a equals to what we are writing? F by a equals to y into delta L by L. Then we are going to discuss about here thermal stress. What is the thermal stress? We should consider the temperature. When we are using the temperature, when you are increasing the temperature, how can we find out the stress? That is called the thermal stress. Thermal stress. See, from the thermal properties of matter, you know that alpha equals to change in length by original length into change in temperature. Change in temperature. So here already you know that instead of delta L by L, what we are writing? Alpha into delta T. What is the alpha? Temperature coefficient of resistance, but here it is the temperature coefficient of linear expansion. Alpha is the coefficient of linear expansion. Then thermal stress we are writing F by A equals to y into, instead of delta L by L, we are writing alpha into change in temperature. See, these many formulas are there, belongs to Young's modulus. Then we do one problem also here. If alpha equals to 0.00012 per degree centigrade, then y equals to 2 Newton per meter square. Then change in temperature is the 100 degree centigrade. Then how to find out the thermal stress? Simply you should multiply all these parameters. It should be right 12 into 10 to the power of minus 5 into 2 into 10 square. After simplification, stress equals to how much? 24 into 10 to the power of minus 3 Newton per meter square. Like that we can calculate the stress. Suppose we are taking another application, look here. Two wires. First one Young's modulus is y1. Second one Young's modulus is y2. Same load you should apply here. In this case, what is the resultant Young's modulus? Y equals to 2y1 y2 by y1 plus y2. Like that you are taking two wires in parallel, like that. Same load you should apply. This is the y1 and this is the y2. Here resultant Young's modulus is y1 plus y2 by 2. You can call this is the series and this is parallel to connect the wires. This is about the detailed explanation of the Young's modulus. Now we are going to discuss about the bulk modulus. What is the bulk modulus? This is the bulk stress by bulk strain. Bulk stress by bulk strain is called what? Bulk modulus. See, bulk modulus is represented either K or B, your wish. So K equals to bulk stress, whatever the stress formula is same, but change in volume is the delta V by V we are taking. So it should be right, instead of F by A we are taking pressure also, delta V by V we are taking minus. Why? Volume is decreasing. So bulk modulus K equals to minus PV by delta V also we are writing. This is the bulk modulus. The next one is the rigidity modulus. Rigidity or shear modulus. In this case it is represented by eta. Eta, what is the formula? Stress is same, but instead of theta we are taking x by f. But here this is different, FL by AX we are writing. This is about the rigidity modulus. So these are belongs to Young's modulus, rigidity modulus, and middle one is the bulk modulus. Then we are going to discuss about one more concept, that is the already you know that Hooke's law. Within the elastic limit, stress is directly proportional to strain. Stress is directly proportional to strain. So in this case, what we are taking, you know that there are three types of moduli, that is over. We have to discuss behavior of wire under gradually increasing load. Stress we are taking here, then strain we are taking. Otherwise we are increasing the load. Then what happens when we are increasing the force? Force is on y-axis. Then elongation we are taking on x-axis. When we are increasing the force, elongation also increases. And this point P is called the elastic limit. Elastic limit or proportionality limit. Sorry, this is the proportionality limit. What is the proportionality limit? It obeys the Hooke's law. It obeys the Hooke's law. Till here, even we are removing the force, it comes back to its original position. This is called the proportionality limit. Then we can observe one more point here. This is the Q. What is the Q? Elastic limit. This is the elastic limit. From this, what we are understanding, see, till here when we are applying the force, it comes, removing the force, it comes back to original position. It obeys the Hooke's law and it obeys the elastic nature. But P and Q, here when you are removing, it comes back to original position, but it does not obey the elastic nature. That's why this is called what? Elastic limit. Then this is the yielding point here. Then next one is the breaking point. After this, what happens? It is permanently losing its elastic nature. This is called the, here O dash is called the permanent set. Permanently it is losing this one. This is the permanent set. Then afterwards, even we are applying the small force increases also, it becomes too thin, and this E is the breaking point. This E is the breaking point. So this is about the behavior of wire under gradually increasing load. But here you remember that between R and E, if the distance is more, those are called the brittle materials. And the next one is the ductile materials. See, ductile is this distance is more, brittle means that distance is less, ductile means we can make like ornaments also. And when this is immediately breaks means that is the brittle, we can't made with the ornaments and all these things. So this is the behavior of a wire under gradually increasing load. Then we are going to discuss about what is the strain energy. What is the strain energy? Strain energy is nothing, is that we have to calculate the energy per unit volume. See, strain energy is nothing but energy per unit volume. Simply you remember that half into stress into strain. Half into stress into strain is called the strain energy. It should be right half into, instead of stress, what we are taking Y into, you know that Young's modulus, what is the formula? F by A delta L by L. F by A is the stress. Instead of stress, how can you express? That is Y into delta L by L. Into strain also we are taking. So this is the strain. It should be right half into Y into, see, delta L by L is also strain. This is also strain, means we can write it strain square also. When we are taking this Young's modulus, we are writing half into Y into strain square. Not only this one, half into, we can take it stress into, but instead of strain, you can take it stress by Y. Stress by Y. See, delta L by L is how much? F by A is the stress divided by pi. So it should be right half into stress square by pi. So look that question properly. Suppose they are giving Y equals to 4 Newton per meter square and stress equals to 2 Newton per meter square. Find the strain energy. Means immediately what we are taking, we don't know about the strain. We know about the stress. Immediately you can go this one. Half into stress square is the 4. Young's modulus is the 4. This is 0.5. like that. If we know only strain is the like 4. This is 4 Newton per meter square. Then how to find out the strain energy in this case? So in terms of strain we are taking half into Young's modulus is the 4 and strain square is 60. After simplification you are getting 30. So like that we can use the strain energy. Then our next concept is the Poisson's ratio. What is the Poisson's ratio? It is the ratio of lateral strain by the longitudinal strain. Suppose one wire we are taking, we are applying the load like this. One wire it is, we are applying the load. Then what happens? It elongates and it becomes too thin. So what we are observing? Decreasing of the radius. So that's why this formula is sigma equals to the ratio of lateral strain by longitudinal strain. Longitudinal strain. This is called the Poisson's ratio, and sigma equals to minus delta R by R divided by, already you know that, delta L by L. So this is about the Poisson's ratio. Now we are going to discuss about different forms of these relations. Look here, relation between y, k and eta. You should by heart this one. See, 9 by y equals to Young's modulus, 1 by bulk modulus plus 3 by rigidity modulus. Then it should be right y equals to 9 eta k by 3k plus eta also we are writing. Not only this one, we can give Poisson's ratio and Young's modulus relation 2 eta into 1 plus sigma. Sigma belongs to Poisson's ratio. Then it should be right y equals to, in terms of bulk modulus, 3k into 1 minus 2 sigma. Then sigma equals to, we can write it from this, 3k minus 2 eta by 6k plus 2 eta. What is the use of this one? Look here. Suppose we know that sigma equals to 0.5 and eta equals to 4 Newton meter square. Find the Young's modulus, means which formula is suitable for this. Directly we can able to use this one. Then y equals to, what we are writing, 2 into 4 into 1 plus sigma is the 1.5. 1.5 into 4 is the 6 2 is 12 Newton per meter square. So you must by heart. In this chapter, what you want to by heart means this concept only. This is the relation between y, eta, then bulk modulus, and few more relations you should remember that. Relation between volume strain, lateral strain and Poisson's ratio also I am giving. So you have to by heart this also. Delta V by V equals to 2 into delta R by R plus delta L by L. This is the longitudinal strain and this is the lateral strain. When you are adding these two, we are getting which strain? This is the bulk strain we are getting. In terms of Poisson's ratio also you can express 1 minus 2 sigma into delta L by L. 1 minus 2 sigma into delta L by L. So this is about the mechanical properties of solids, and one more concept is that is whenever the body breaks, means it is that formula is that stress equals to its weight by area of this one, then easily you can calculate. So anyway, these are the basic formulas from the mechanical properties of solids. It is the very easiest chapter. Don't leave this one. Few formulas are there, and don't go that much typical questions they won't ask. So try to by heart these formulas, and you think and you remember that logically that formulas, but last formulas only you should by heart. Thank you everyone. Please subscribe my channel.